So today I'm going to talk about water resource engineering project. So first of all, I want to introduce my group member, which is me, Derek Keith WENNEDY, then Muhammad Haziq, Daniel bin Muhammad ZALALUDIN YUSZAINI, and then HUSNINA BINTI ZURAINI, and Leslie BINIUS, and last but not least AMRI bin AXZIMI, and our lecturer Professor MADYA Dr. SITI NAZAHIYAH BINTI RAHMAT. So I'm going to start with the introduction, which is drainage is a natural and artificial evacuation of the surface and subterranean water from an overflowing region. So a drainage system is a pattern formed by the streams, the river, the drains, and the ponds, in particular the drainage basin, which is the catchment. So as you can see, the drainage on the slope can help us to reduce the risk of soil from collapse due to soil irritated and erosion. So in Malaysia, the drainage act as an important infrastructure because Malaysia is typically a tropical weather country and rains all year round. So thus the proper drainage system was provided to control the runoff of the flow and the flood. So next is the background study. So the focus is on predicting the potential impact of the proposed residential development on local water resource and drainage network, and emphasizing the critical role of water in the region and the necessity for sustainable drainage solution. So as the comprehensive analysis, we can consider the implementation of the practice that promotes environmental responsibility and the resilience in the face of increasing the development, and we also ensuring the long-term health and the sustainability of water resource within the community. So that's our background study. As you can see, there are three problems of the study. So as the first one, as you can see, it presents a critical need to address the efficient water resource management and the sustainability drainage system within the evolving urban landscape. As you can see, the second one, the absence of the robust water resource management strategy and adaptive drainage system may exacerbate the flood hazard and compromise soil integrity and threaten the area ecological equilibrium. So as you can see, the third one is the absence of sustainability drainage system tailored to the evolving landscape could lead to erosion, waterlogging, and environmental degradation. Besides that, it also highlighting the pressing needs for adaptive solutions that safeguard the land natural hydrological balance. So as for the scope of the study, we got three. First, we want to emphasize the sustainability, stormwater management, and climate change adaptation strategies within the plan of the residential area. And then the second scope of study is to be committed to implementing innovative stormwater management system that comply with MASMA standard. And last but not least, to mitigate the potential flood risk, optimize rainwater utilization, and preserve natural drainage pattern, and ensuring alignment with MASMA directives for sustainable stormwater management in urban setting. So that's all for our scope of study. So for the next literature review, I will pass to HUSNINA. That's all for me.
Okay, for the literature review, the hydrological cycles is dependent on various factors and is equally affected by oceans and land surfaces. In the case of the land surface, vegetation plays a vital role in the maintenance of the hydrologic budget set by Pilker and Yogi 2009, and also to calculate and design for the modification of the river channel. The values of Manning roughness coefficient are also referred to MASMA second edition. Roughness coefficient are describing the resistance to flood flows and the floodplains, set by Ahmed and Schneider, 1989.
Hi, I'm Leslie, and I'm going to present for the methodology for our project. So the first method is hydrograph method, and the second one is rational method, which both are used to estimate runoff, and we use MASMA second edition for our reference. And the rational method is to make following assumption. such as the maximum flow rate and the rainfall intensity. And the design for the drainage types and dimension are referred based on the JIGA drawing, section 3, drainage work with the 2014. Okay.
I continue. The next part is data analysis for hydrological and hydraulic analysis for road drainage. They have two parts. The first part is to calculate the Q capacity for proposed design. There's a 5-step, and we got the Q capacity is 1.07 meter cube per second. Next, we calculate for the determine the Q rationale. There are 7 steps. We need to calculate for Q for development and Q for undevelopment. For Q rationale, we calculate for Q undevelopment, and we got 0.0267 power of -3 meter cube per second, and for Q development area is 0.0713 power of -3 meter cube per second. For comparison, Q proposed bigger than Q development and Q undevelopment, so 1.07 meter cube per second larger than 0.01713 power of -3 meter cube per second and more than 0.0267 power of -3 meter cube per second. So they pass for this drainage to support the quantity of flow rate for that node 1 to 2, and step repeat for other nodes until the end. Next, for the old node, we calculate in the spreadsheet by following the manual calculation, and then we summarize it. All node pass using this size drainage proposed. Comparison by Q proposed is larger than Q development and larger than Q undevelopment. That's all from me. Thank you.
Assalamualaikum. I will continue for the next part, which is the result of the data analysis. As you can see, the development area will not get overflow runoff because all the development flow rate in the analysis are more larger than the undevelopment flow rates. Also, the proposed drain of 600 times by 750 mm include the freeboard of 450 mm has passed the required velocity for safe clean and can cater the flow rates of the development area that will flow into it. For drainage system detail, drainage system has been determined and the proposed drain size has been selected based on the size chart that will be provided by the selected concrete factory, which the concrete selected factory that selected in this project is the API, which is stand for Aliens Precast Industry, and the selected size is 600 times by 750 mm. As you can see in the drainage system detailing, the purple stands for the drainage system with the flow has been determined at the study area. These are the detailed design of the box covered based on the size chart provided by the API factories. As a summary of a drainage at every node, as we can see in the tabulated form, each node has been provided with box culvert with the size of 600 times 750 mm give us the result of pass, which means the area will be flooded with the provided drainage. Therefore, all the proposed project will experience the better drainage system and the area will not get flooded during the consideration of ARI. Although the drainage can accommodate the flow rate of the project area, maintenance must be done by local authorities or other entities that involved with this maintenance operation. By far, that's from us. Thank you.